Hi to all the math students out there from Mrs. Marcellus and my faithful furry friend, Barkamedes. In this lesson, we're going to learn to find the surface area of pyramids. Today's learning objective is, students will find the surface area of a pyramid by deconstructing the figure and applying area formulas to its net. Ooh, we get to do more deconstructing today, Barkamedes. Sounds fun, doesn't it? Before we proceed, there are some things that we need to know about pyramids. A pyramid is a three-dimensional figure with at least three triangular sides that meet at a vertex. A pyramid is named by its base shape. For example, if the pyramid sits on a square, we call it a square pyramid. If the pyramid sits on a triangle, we call it a triangular pyramid, and so on. The triangular sides of a pyramid are called lateral faces. And the height of a lateral face is called the slant height. However, this doesn't change anything about how we find the area of these triangles. In general, surface area is the number of square units needed to cover the surface of a three-dimensional shape. A net is a two-dimensional representation of a three-dimensional shape. The surface area of a pyramid is the sum of the areas of the base and the triangle faces. First, we'll find the area of the base shape that it sits on, and then we will add the areas of all the triangular faces. Because we're finding surface area, we'll use a label of units squared. What do you say, Barkamedes? Are you ready to try a few? Then let's go to our first example. Let's find the surface area of this pyramid. As you can see, it has a square base. Because the pyramid has a square base, all four of the triangles are going to have the same area. One way to approach finding the surface area is to fill in the net. We can start with the square base. The square base of our pyramid is 8 by 8. 8 by 8 is 64 inches squared. Next, we need to find the area of one of the triangles, which are also called the lateral faces. Each triangle has a base of 8 and a slant height of 12. We will multiply 8 times 12 and then divide by 2. This gives us an area of 48 inches squared. As I mentioned before, because the base of the pyramid is square, each of the triangles or lateral faces will have the same area. Now, to find the surface area of the pyramid, we will simply add up all the pieces. The surface area of our pyramid is 256 inches squared. Of course, the net is just a tool, and some of you might prefer to find the surface area without using the net. We can always just think of what shapes make up the pyramid, find their areas, and add the pieces together. We know that we have a square base, and the square is 8 by 8, or 64 inches squared. We also know that there are four triangles. The area of each triangle is 8 times 12 divided by 2, or 48 inches squared. Since there are four of them, we will multiply 48 times 4, which equals 192 inches squared. Then you just add 64 plus 192 to get the total surface area of 256 inches squared. And some of you out there might be thinking, hey, I know an even easier way. I know that I'm going to have my square, which is 8 times 8, or 64, and I know that two triangles make up a rectangle. I don't need to divide by 2 and then multiply by 4. To find the total area of the triangles, I could simply multiply the base times the height. This makes up two of the triangles. 8 times 12 is 96, and then in order to account for the other two triangles, I just need to multiply that number times 2. That gives me a total of 192. We will again add 64 plus 192 for a total surface area of 256 inches squared. As you can see, there are several ways to approach finding the surface area of a pyramid. You should do whatever makes most sense to you. Let's find the surface area of this pyramid. We can see that the base is a rectangle. To calculate the area of the rectangle, we will multiply 8 times 4. It has an area of 32 feet squared. Because the base is a rectangle, all four triangles will not be congruent. We will have two of one size and two of another size. Two of the triangles will have a base of 8 feet and a slant height of 10 feet. To calculate the area, we will multiply 8 times 10 and divide by 2, which equals 40 feet squared. This will be true for the opposite triangle as well. The other two triangles have a base of 4 feet and a slant height of 10 feet. To calculate the area, we will multiply 4 times 10 and divide by 2. Each of these two triangles has an area of 20 feet squared. Now, in order to find the total surface area, we will add all the pieces together. The surface area of this rectangular pyramid is 152 feet squared. It is also pretty easy to calculate the surface area of this pyramid without using the net. We can start with the rectangle, which is 8 times 4, or 32 feet squared. Since we have two triangles that both have a base of 8 feet and a slant height of 10 feet, we can calculate their areas all at once. There's really no need to find the area of one, then divide by 2, and turn around and multiply by 2. We can calculate them both at the same time by multiplying the base times the slant height, or 8 times 10, which is 80 feet squared. With the other two triangles, we could do the same thing. Instead of dividing by 2, then multiplying by 2, we can simply multiply the base of 4 feet times the slant height of 10 feet for an area of 40 feet squared. Then to get the total surface area, we will add 32 plus 80 plus 40, which equals 152 feet squared. In this case, we have a triangular pyramid, and we're told that the base triangle is equilateral. This makes it a little bit easier because that means that all three of the other triangular faces are going to be congruent. Of course, you can draw yourself a net of a base triangle with 3 triangles sticking out from it, but for this one, I'm just going to work with the figure. The first thing we can do is find the area of the triangular base. We can see that it has a base of 4 and a height of 3. The area of the triangular base is 4 times 3 divided by 2, or 6 inches squared. Now that we have that figured out, we need to find the area of one of the lateral faces. Because that base triangle is equilateral, all three will be the same. Each lateral face has a base of 4 inches and a slant height of 8 inches. To calculate the area, we multiply 4 times 8 and divide by 2, which is 16 inches squared. Since the pyramid has 3 congruent lateral faces, we will next need to multiply 16 times 3. The total area of the 3 lateral faces is 48 inches squared. The final step in finding the surface area of this triangular pyramid is to add the area of the base triangle plus the area of the lateral faces. 6 plus 48 equals 54 inches squared. Well, Barkamedes, that was actually kind of fun, wasn't it? What's that you said? Yeah, you know, the nets of the pyramids do look a little bit like throwing stars. No, you and Pythagoras cannot throw them at Furkat. That wouldn't be very nice now, would it? Hey, you know, I've always wanted to visit the pyramids in Egypt. Maybe we should go do some research and see what it would take to book a trip. What do you say? Well, it looks like we've got some work to do, math students, so we're going to say goodbye for now.